This section is an introduction to what is biostatistics and also discusses types of data. So what exactly is biostatistics? Statistics is the science of exploring the collection, organization, analysis, and interpretation of numerical data. So biostatistics is just the application of those statistical methods to biological and health sciences types of research problems. In biostatistics, we will be learning how to summarize observations, we'll be looking for patterns and trends in our data, and also learning how to account for variability in our data. Biostatistics in general, though, is used to make inferences about future situations or a larger population than what we have time or resources to survey. So most of the time, what we're doing is taking a small sample of the population that we're interested in and using information that we gather from that sample to make inferences about a larger population. There are different areas of research and application of biostatistics, and those include study design, analyzing and interpreting data, and also development of new statistical methods. When you think about different steps in a research project, you can look at them and think about where statistics would be involved in each step. In planning a study, statistics is used in the study design for randomization plans, sample size calculation. Execution refers to the actual data collection, and then there's data processing and analysis. And statistics is also useful in presentation of the results to find the best and most easily understood way to present the results that you have. And correct interpretation of results is key in disseminating the information that you have found. And then also all of that goes into publication and helping you to create a good publication. So in this course, we will start talking about how to describe data, both graphically and numerically. We'll spend a little bit of time on probability and theoretical probability distributions. And then most of the course will be spent learning about statistical inference, mostly for 1 and 2 groups of data, but we'll do a little bit with multi-group. And our inferences will focus mostly on confidence intervals and hypothesis testing. So to start out, we have to understand types of data. Understanding what type of data you have is really important because that determines everything else that you will do. So it'll determine what summary measures you use, what graphs you'll use, what analysis procedures you'll use. It determines everything. So this is a really crucial step. The 2 main types of data are categorical and numerical, and these are the 2 types that we'll focus on mostly in this class. Categorical is exactly what it sounds like. It's when data falls into different categories. So some examples are blood type, gender, or just in general success or failure. So each observation would be categorized into one of those groups. Numerical or quantitative data is any data information piece that is a number. So some examples are weight, blood pressure, or it could also be things that are counts, such as number of pregnancies. Categorical data can be further divided into binary, nominal, or ordinal data. Binary data just means that there are only 2 categories. So for example, male, female, smoker or non-smoker, or presence or absence of a disease. Nominal data has more than 2 categories, but they don't have any type of ordering. So for example, blood type, A, B, AB, or O. There's no ordering to those categories, but there are more than 2. So binary is a special case of nominal where there are only 2 categories. Ordinal data is when the categories have to be arranged in a certain order. So for example, disease stage 1, 2, 3, or 4. So stage 4 is worse than stage 1, so that explains the ordering. Or pain level, none, moderate, severe. So anytime there's a natural ordering, that data is considered ordinal. Numerical data can be divided into discrete and continuous data. Discrete means it can only take on certain values, and a good example of this is counts. So number of pregnancies or number of swollen joints. These variables can only take on whole numbers, so 0, 1, 2, and so on. It doesn't have to be limited to whole numbers, but that's the most common type of discrete data that you'll see. Continuous data can take on infinitely many values within a specified range. Usually this is limited by the measuring device, but still, in theory, the observation could take on any number in that range. Measurements are the most common type of continuous data that you'll see. Height and weight are two examples. And sometimes continuous data is reduced to categorical data to make displaying that information easier. So for example, you could divide tumor size, which is a continuous measurement, into a category. Or you can divide age, which is also continuous, into age groups. Sometimes this might be done to protect individuals' identity or just to make it easier to display. One thing I would recommend, though, is that when you're collecting data, that as much as possible you collect numeric data, because you can always recategorize that later. If you collect the category, then you won't ever know the actual value. So for example, if you collect age group and someone selects the group of 30 to 39, you would not know their actual age. However, if you collect the actual age and you wanted to put that into categories later, you'd be able to do that. Sometimes there's some confusion between discrete and categorical data, and this often occurs if we have something that's discrete, but there are few options that the variable takes on. So the difference between categorical and discrete numerical data is that in discrete data, the numbers actually mean something. In categorical data, the numbers are just a label. Here are some examples. So if we look at, for example, the number of swollen joints, and our options are 0, 1, 2, or 3. Here, 0 means 0. So the response of 0 means the person has no swollen joints. 1 means they have 1, 2 means they have 2. And 2 swollen joints is twice as many as 1 swollen joint. So here the numbers obviously mean a count, so that would be discrete. In the stage of disease, where your options are stage 1, 2, 3, or 4, here the numbers are just labels. We could have named stage of disease stage A, B, C, or D, and stage D would presumably still be worse than stage A. However, it's not a number that has a numerical meaning, so these are just categories. There are other types of data, and I have a few examples here. This class will mostly consider numerical data, just continuous data, and categorical data as well. Some types of data that you see often are scores or visual analog scales. Visual analog scales and scores are sometimes used to rate the same things, but they're really just rating scales. So for example, a numeric pain score, when you are in the hospital and they ask you to rate your pain from 0, meaning no pain, to 10, meaning the worst pain you've ever experienced. That's a numeric pain score, and it's very subjective, and it's really based on the individual. For the visual analog scale, there are similar scales to the pain score that they use with children, where a frowny face means it hurts and a smiley face means that it doesn't hurt. And these are often used with small children or people who may not understand the numbers. There's also censored data, and that's a data value that is unknown. It's not one that's missing, it's just unknown because that observation has not occurred yet. This is common in time to event situations. So there's the end of the study period, for example, and the event of interest has not occurred in certain patients. So that would be considered a censored data point. So in summary, biostatistics is the application of statistical methods to biological and health sciences research. And for types of data, this course will focus mostly on data that is categorical or numerical.